So back to the pendulum.
Yeah, okay, sorry.
Back to reality, right? So you got a thing
exactly.
that swings back and forth, and the reason why the lines trace differently is because something is spinning underneath it, right?
That's the Coriolis force, yeah.
It's not a force. It's not a force. It's because something is spinning. There's no force acting on the ball. You realize that,
That's
right?
what I'm saying. You should be able to put an accelerometer inside the ball and not read any left to right force. You should only get the swinging, the back and forth force. You would never get the force on that axis with an accelerometer like inside the pendulum or the ball on the ball or whatever you're swinging.
Yeah, if you mention the word force in that experiment, you don't know what you're talking about because there's not force is not involved in this.
I don't know how we don't have that already.
I mean, you're just measuring the drift.
That would have been one of the first things I did if I was these guys.
Yeah. So I would say, yes, if you're having an accelerometer inside a ball, you would measure no forces side to side. That's completely correct. The problem, not the problem, but what is the Coriolis force, why it's called a pseudo force, is because it's like the ball is causing a force on the frame, the reference frame, the other reference frame, like the Earth's reference frame. So the Earth is spinning. So look, if you're standing on Earth and you're observing the ball, it's as if the ball is twisting, but the ball is not twisting. But if you were to measure the force,
it's not a force, bro. It's just a visual effect. Until you understand that, you're not gonna understand what Coriolis is.
Yo,
it's not a force. It's not a pseudo force.
Yo, can I get in?
Yeah,
so
maybe one
real quick.
I wasn't actually. I wasn't actually.
Yo, all right. Next, I got next. Go ahead.
Sorry, I wasn't
let SC finish. Now SC was talking. I interrupted him. Go ahead.
He cut me off first, but okay.
I didn't speak once today without getting cut off. I'm not even going to bother, man. You guys don't even know what this is, man. You guys don't even know the fundamentals of this. Go ahead, talk amongst each other.
Sorry, I'm speaking and I'm having like 1 second break when I speak, and when I had a second break, you started talking. I wasn't actually finished. But okay.
You had a coffee break. You had a coffee break while you were speaking. Got you, bro. Yeah.
No, that's how I speak. Maybe I need to speak quicker. Okay. I don't know. So I was just saying that the force that you're the inertial reference frame, the ball appears to twist. Sure, if you have an accelerometer on the ball, they are not going to measure a force. But if you are attached to the ground, which we are, if you're standing here on the ground, you are going to measure a sideways force. The ball is moving towards you sideways. So that force is, sure, it's not measuring a force on the ball, but between you and the ball, there is a force because that ball is going to crash into you. That's a force.
No, you still don't understand it, man. There is no force involved here. You have a ball swinging back and forth, and you have something rotating under it. There is no force here. It's a visual effect. The reason the person on the ground on the spinning thing, it makes looks that the ball is curving, it's because he's moving, not the ball. There is no forces involved here on the ball. If you don't understand that, you don't understand the basic thing about this, bro.
Yeah, I agree with you. I don't if that ball moves into you or you move into the ball, that is for me, it's still a real thing, right? You could say it's not a force, but it's real. Like you're gonna crash into each other. You can't say, well, it's not real. It's a visual effect. Like if it was just a visual
effect, it's fake. It's not real. It's not real. It's not happening. It appears. It's appearing to do what you're saying. If you're talking about the Coriolis effect, is that what you're talking about?
You're actually crashing into each other. What you're saying is not happening.
It's like saying there's not a force involved with a wrecking ball when you knock a building down, right?
Yeah, it's clearly like if a car is turning. If a car is turning, the car is a non-inertial reference frame. You are inside the car is an inertial one. Are you going to say you're not being pressed against the side of the car? If it's like skidding, of course it's real.
Yeah, it's a good question.
You'll smash your head into the window, right? Like it. Of course, that's a Coriolis force. It's very real.
No, that's not what Coriolis is.
The thing is, it's not an actual.
That is Coriolis force.
Hold on.
No, it's not.
All right, man. Hold on a second. It's not an actual force. I just said if you were to put an accelerometer in there, you wouldn't measure a force there because there is no force there. When they say Coriolis force, it's like the amount of force you would need to turn to keep on a straight line or the amount of force that would be there if this was actually curving. However, that's not what's happening. If you throw a ball in a straight line and then some guy gets under on a merry-go-round and spins around, there's no force pushing the ball left or right. It's just
There's
not
the
a force.
Coriolis effect. Then there's the Coriolis force. Like, you got to get the
There
two.
is no force, though. That's
I know,
what
but
they're
people
saying.
get
There
them
is no force.
right. People get them
Well,
mixed up also, though. But like the
there is a.
Coriolis effect is fake. It's
But
apparent. It's not
No,
happening. It's not
they just
happening.
say that. Yeah, but that's not true. On a merry-go-round, there is a force, right? Because
Well, yeah,
when you throw
the
the ball, your
effect.
arm is also moving in a circle, so it's actually imparting force on the side. They just
The
can't prove the
effect
Earth's
of it.
moving, so they have to say, "All right, you can just talk the whole time I'm talking."
Go ahead. Well, like
man,
the
Jesus
effect
Christ,
is
man.
is
Hold
not
on.
happening. It's
Nah,
not
man.
happening.
No.
Right.
Just let Quap finish, please.
Yep.
I did finish. I just had to hear people talking all the whole time.
I mean, it's Bear, dude. I don't know. I've told him a million times.
Everybody's putting their 2 cents in, and it's too many cooks in the kitchen. And this is just the worst I've ever heard about Coriolis. Like, this is terrible, man. Terrible.
So that thing that Cole showed me, that video he sent before, if you put an accelerometer in that thing, you're gonna measure a force.
Yeah, man. Coriolis is spinning in his grave right now, man. Because of how bad,
I think it's not a force in the classical sense of a
He's
force, but
pseudo-spinning in it.
you can make predictions and you can measure the effects of it. So
It's not a force in any sense of the word because there is no force there. Like I
Well,
said,
there's-
if I throw a ball in a straight, hold on, here's the example, bro. Just to show you there is no force there. If you throw a ball in a straight line and somebody gets on a merry-go-round and sees it curving, there's no force curving that ball. The ball's going in a straight line.
right, it applies to the reference frame in which the Coriolis
Right.
is applied, right?
Yeah, but there's never an actual force though. There's never a force. You know what I'm saying? That's not a
That's why I said
Well,
not in the
depends on the
classical sense of
paradigm,
it, but like hurricanes rotate, right? And they can be predicted and they can be measured.
Right, we got to be more specific because even like pendulums, like if you were to theoretically put an accelerometer on a pendulum swing, it's gonna feel, it's gonna pick it up. It ain't gonna be zero, dude, because it's not in free fall. Now,
Then you're saying,
momentarily,
if that's the
hold on,
case.
momentarily, that pendulum as it approaches its peak, right? Pendulum, I forget the technical word. It's peak vector or whatever, right? And then for that moment, pause in time, it's in 0 G's, right? It's in free fall, and then it swings back down again. And when it swings back down again, it will pick up the centrifugal force, and it'll read in G's.
No, if you're saying you were to put an accelerometer in it and it would read the left to right acceleration, the precession acceleration, if it did read that, then it would definitely 100% not be the Coriolis effect. In fact, you could rule that out. You'd be like, all right, it's not the Coriolis effect.
Right. You're not. You're talking about something completely different. When you say the Coriolis effect, that is not happening. It is a freaking fictitious force.
We
It
know,
appears to
guys.
happen from your vantage point. The ball isn't curving; it's going straight. It appears to curve. That's what the Coriolis effect is.
Right.
Period.
No doubt, no doubt. And I don't think anybody here is denying that
No, I would deny that.
The Coriolis effect is nothing more than an illusory phenomena. It's an illusion. In their paradigm, it's an illusion. There's no force. It's a pseudo force. It's simply due to reference frames. There's a non-rotating reference frame and a rotating reference frame. One is inertial and one is non-inertial.
It's literally the same as gravity, though, in that sense. Like, it's a pseudo force, just like gravity. Gravity causes things to move. There's a force of gravity.
That's begging the question, though. That's not.
Explain why, and how is that begging the question? I just made it.
You've never. These are all. Yeah, this is. You're
in our paradigm, because you use that term. Well, you said in our paradigm, so you said.
Dude, how is he gonna just ask me a question and not let me answer and phony mute me while
I know. I thought
this is the type of
Ryan
tactic.
is about to answer your question, dude. You want to hear it, or just let him respond?
Go ahead. I'm sorry. Go ahead.
Okay. Yes. So he's parallel. He thinks that things free falling is a parallel to 0 G's, right, in free space. That's basically what he's saying. It's the same. So we shouldn't measure, because according to Einstein, you can't measure the Earth's motion around the sun. It's in free fall, right? So any free fall on the Earth is equivalent to the Earth moving around the sun. Correct or not correct?
Sure.
You say sure?
Yes, that's fair. Go ahead.
Yes.
That
Okay.
doesn't even make sense. What do you? Are you
So
sure you're sure?
Let me make my point because he's missing the point. The point is that it's a pseudo force. That's literally the analogy. So they're both pseudo forces. That's why they're comparative, and it's not begging the question.
Yeah, but if
it's just a statement.
If it's comparative, though, hold on. If it's comparative, that's like that. What are you saying? Like the ball, say you drop a ball, you're saying the ball's not actually moving down.
No, I'm saying that they're not forces in the classical sense of a force. They cause other things. They cause other things to have force, right? Like gravity indirectly.
In order for it to be the same
out of your
thing.
mouth, please. You're very difficult to.
Is it too close? I'm sorry.
The thing is that everybody gets this confused, and it's so silly because they say, George Musa, you could think of it as a force, kind of think of it as force, but it's not really a force, non-force, force. It's freaking absurd.
No, it is. No, the thing is, it is actually a force, right? That in my paradigm, in my worldview, it is a force. In Einstein, it's not. It's a pseudo force.
If
and it's
you
due
have
to
it,
inertial reference frames and non-inertial reference frames. Go ahead.
If you have gravity as not a force, then you have mass accelerating with zero force. I mean, we can all put two and two together, right? Mass accelerating, no force. What was Newton's second law? That totally debunks Newton's second law. Newton said if you have mass accelerating, that equals a force.
Globetard logic.
I wouldn't throw Newton out the box. I mean, they had to, though. They had to account for the orbit. They would have had to scrap the orbit or do whatever this, GR thing was.
I think you guys are just misunderstanding what pseudo force is.
I understand. It means not real.
No,
Not
it's
real,
a real
yeah.
force.
No, that's not what
It's
it
a
means.
real force. Yeah.
Well, we just went through it with the Coriolis.
I know, and I just posted
how it's not. We just went through how the Coriolis is a force. You wouldn't measure a force left to right. It's not actually even deviating left to right. There's no force pushing it left to right. It means no force, not a force.
No, it does
That's
not
what
mean no
pseudo means.
force. No.
Yes,
Well,
it
I
does.
just posted the definition in the chat of what it means.
I know, but when you're dealing with the Coriolis effect, that's a pseudo force, and there is no force there. There is zero force there. Literally zero force. Nothing's pushing it left to right. Just because you get on and off a merry-go-round, it's not going to change what physical forces are acting on the ball.
Yeah, they claim it's due to reference frames, bro.
Who said it was a pseudo force to begin with?
Einstein.
Who Coriolis?
Einstein didn't say Coriolis was a pseudo force to begin with. I'm talking about just.
Well, no, I'm saying it goes back to Newton.
Said it was a pseudo force.
I may have mentioned it.
Because it may not be a pseudo force.
No, it is.
May not be considered a pseudo.
It is a pseudo force.
It's a pseudo force.
Not real.
But a pseudo force. A pseudo force isn't considered to not be real.
I know what a pseudo.
That's what I'm trying to tell him. I know. Is that guy sounds like he's on your side too, right? What's your name, guy with the loud mic?
Yeah, I moved it off. I had a different setup today. Icy Spent.
A
pseudo force is most certainly a real force, though. That's what I'm trying to say. Just like Cole.
Yes. It's like if you got centrifugal force and you're spinning something.
Okay, you guys are saying a pseudo.
I was talking. Can I finish, please, real quick? If you're spinning something around, if you're on, and I'll try to make it real fast. I'll quit talking so slow. If you're on a ride at an amusement park and you're on one of them things that spins you around, your body's trying to go straight. Yet the whole time, because of momentum, you're trying to go straight. But yet the whole time, the machine is pulling you sideways. As you're trying to go straight, as you're trying to go straight, and the machine is pulling you sideways, you're feeling a force pushing you outwards. But that is a pseudo force.
No, that's not what you're
feeling.
Hold on,
let me just get this out, bro. Please, man.
I'm not saying that's Coriolis. I'm not saying that's Coriolis. I'm saying that's a pseudo force.
All over the place. It's a hot mess, bro. I feel bad, yo.
I just described pseudo force is all I did. Go ahead.
Okay.
No, you didn't. You described centrifugal.
Okay, Bear is first in the list. Bear first, then me, then Jeremy.
Just hold on. There is a 100% proof that it's not a force. The Coriolis effect is not. There's no force there. They call it a pseudo. They say there's a pseudo force there. It's 100% provable that there is no force there. Do you disagree with that?
No, I agree that there's not a force there.
Okay, so no force. No force.
No, there is a force because of the rotation of the Earth. Okay, it's generated by a rotating reference frame. It's as simple as that.
No,
it's still a force.
No, the Coriolis effect. When you have the Coriolis effect, just Ryan, you're on a whole different thing. That's not, you're talking about something else. That's not even the Coriolis effect, the thing you're talking about.
Bro. I'm gonna have to call Whitson in here. Every time I have to bring this up, then it's like you forget, Jeremy. Like you just.
I understand. You think there's this thing that's actually causing the
hard to
effect
teach a
that is an
dog.
actual force. I know. I
An old
understand,
dog
but
new
that's not the
things, dude.
Coriolis effect, though. That's something else.
Bro, Lion had a stripper girlfriend. He knows about the Coriolis effect.
Dude, no, when you're talking about things spinning and pushing out, that's freaking not the Coriolis.
I
Coriolis
know. Cole's
effect
example was
is
not
just
even of the Coriolis effect.
yeah.
Well, that's centrifugal, but it's also a pseudo force.
Said I was not making I was not describing. I specifically said I was not
I know, that's
describing.
fine.
So why'd you
That's
even
fine.
come in? Why'd you come in then?
Dude, would you shut up? I've been here the whole time.
Let him go. Let Cole.
I've been here before you.
Let Cole
What I
talk.
was what I was describing was a pseudo force. It had nothing to do with the force of something moving in a curving environment. I was just describing what a pseudo force was. Is all.
Okay, but Cole, me and you agree that the Coriolis effect, there's a pseudo, they say there's a pseudo force there that's causing that. And we know that there is zero force there. There is no force, right? We know that. This guy, IC Spin, wants to disagree with us and say there is a force there, which
No, I
is
said it's a
demonstrable
pseudo
that
force.
there's not. Yeah, so no, there is no force there.
Yeah, it seems to me that there's
Right,
The
right,
force,
Spin?
the force does not come from it itself, right? The rotating
There is
reference
no
frame.
force there.
Well, there's rotation of the Earth, and that generates the pseudo force.
The force moving the spinning object, that has nothing to do with.
Wrong.
So if you throw a baseball
Well, no,
and you're
there
on
is
a spinning
there would
Earth,
be
there's going to be a slight deviation based on your
No,
coordinates.
yeah, what you said's wrong. You got to stick to mainstream if you're going to defend it.
Okay, tell me how I'm
You
wrong.
can't just make up your own shit.
No, I didn't make it up.
There's no physical origin of a pseudo force. Period.
There's no physical origin of a pseudo. Yeah, I mean, if there's not a rotating Earth, yeah, I agree. The pseudo force doesn't exist. It exists because the Earth is rotating. That's why it's a pseudo force.
Right. You're saying there's a physical interaction that's
No, I'm not.
causing this force.
It's generated
You're trying to put
because
forward.
there's a
Can you, like,
rotating
take it
reference
out of your
frame.
mouth so it can stop keying up.
Is it still too close? Yeah. I'll push it back. Yeah, thanks for telling me. Carry
I
on.
think you got it turned up too loud in
It's like
Discord, maybe.
constantly
Too.
on.
All right, yeah. It might
Okay,
be
but
better.
as far as the Coriolis effect is concerned, there is no force there. The force is what force would be on the object if there was a force, but there is no force on the object. It's just going in a straight line. It's demonstrable. Pseudo means not real. It's not a real force. There is no real force there.
That's not what it means.
Yeah, when it comes
According
to
to
pseudo
who,
force,
though?
it's not exactly what.
According to
So
who?
you're saying there is. So you're saying there is
Okay.
a real force there. You're saying there is a real force there, Cole, right? What?
No, this is what I was trying to explain a while ago with the centrifugal
Hold on, man.
force.
Just
If you guys
hold on, Cole, please. We're talking about the Coriolis effect.
I know, but it would help if you guys would just understand what a pseudo force is first.
I know we're gonna walk through it. We're gonna walk through it real quick.
Okay.
We throw a ball in a straight line. There's no forces pushing it left or right, right? There is no force there.
Yes,
right?
it's just going in a straight line from its
Okay, then somebody gets on a merry-go-round underneath the ball and starts spinning, and they see the Coriolis effect. There's still no force there.
Still, yes, I would say there's still no
Okay,
force.
so not a real force. There is no real force there, right? We just agreed on that. But then you're going to say you just said it is a real force, or that's not what it means. That it's not real.
What I'm saying is, I don't think that a Coriolis effect is a pseudo force anyway.
It is.
I don't know why.
And the
Who
reason
keeps
it
saying
is,
that?
it is a pseudo force, and I'm trying to explain. There's only a slight deviation, right? If you're on an Earth and you throw a baseball, you're not going to notice it. No one's going to notice it. No one's probably even going to be able to measure it. But there's still a force being applied based on where your coordinates are and based on other factors, how fast you throw it, etc. There's still a measurable force if you have enough scale, maybe not a baseball, but a hurricane, for instance, spins one direction when it's north of the equator. If you call it a hurricane south of the equator, if you call it, what is it, a typhoon or whatever, it spins the opposite direction. It's measurable. You can make predictions based on it, etc. It does exist, and it exists because of the spin of the Earth.
Cole, I'm going to post on in chat for you, right? Sorry.
I was just saying that's why it's called a pseudo.
Call them a post on. It's just the AI overview, but I mean, there's just Google it. Just Google it, dude. Is the Coriolis effect a pseudo force?
But does it say it is or not?
Yes.
Oh yeah,
it is. Okay.
Even that guy, that guy's on your side. That guy that just talked that said it is. IC Spin, he's on your side.
I know, but I would have just thought that it wasn't. Just for me, I would have just assumed
it is because the pseudo part and the pseudo force means not real. Because me and you know when the Coriolis effect. There's not a real force there. Pseudo.
Yeah, but
Right.
it's used in a different sense. It's not pseudo and that it's not a real force. It's used it's called in
that double
science.
speak. Stop it.
No, it's like if you say level, right, and you're measuring geodetic surveying or something, it means something different than saying like level as in a horizontal flat,
Right. So
like tabletop.
So
right?
pseudo force in physics does not mean fictitious force. Got it.
It means
Great.
both. It
Thanks
means
for the
fictitious
input.
too, but it doesn't mean fake, right? They're used in
fictitious.
different. It's a different sense of the word. It doesn't mean it's a.
No,
fake.
it literally
When
means
you apply
it literally
the
means not
fictitious
real
force-
because we can show that it's not a real force there. It literally means not real. There is not a real force in the Coriolis effect.
Can you grab
Not
me a
real.
definition of a fictitious force and show me where it says not a real
Do you
force?
know when to apply the fictitious force? Do you know when it matters? Like when it is an actual like fictitious force and when the force goes away or the apparent force goes away?
Yes.
The apparent
you guys would
force
have let me
exists because there's a rotating reference frame. Said that.
if you guys would have let me explain it a while ago, what I was saying is you feel on
Inertial.
something spinning. I know it's inertial, but on something spinning, you're feeling like something is pushing you outwards. All right. But something is not really pushing you outwards. What's going on is you're trying to go straight while something underneath you is trying to curve. So as you're going straight, you feel as if you're being pushed outwards.
Yes, so
A pseudo
not real.
force.
Not real force, and
It's
apparent
still,
force.
it's still real. It's still acting
No, it's
upon
not
you,
real.
and you
That's
still,
inertia, dude.
and you still feel it.
No, it's
But it's
No,
not a direct
it's an
force.
apparent
That's what it's
force.
called. Yes.
It's an effect that you feel that is not something actually
So a
pulling you.
force there. So
It
there is a force there. Yes.
No, it's not a force there.
Inertia. Holy
It's
shit.
apparent.
Hold
You
on,
know
I
what's
got
Yeah,
it.
you're being silly, man. You're being silly.
You know
Hold on,
what
I
is
got a
apparent?
definition. I got
What
a
is
definition.
apparent?
I got a definition. Right? You want a definition? Here it is.
Posted one
Pseudo
way a while
force.
ago.
It's from dictionary.com. Pseudo force, a physically apparent but non existent force felt by an
Right.
observer in a non inertial reference frame. Not
Right.
real, non existent.
Yes, but it's felt. So that's what we're saying. It still acts upon something. It's not fake. It still acts upon it and causes something to happen.
Dude, you're
to an
not
object.
feeling the force. You're
it's
saying
just
I'm
an
feeling the
apparent.
force, but you're feeling the inertia.
You're feeling the apparent force. It's still there. You're still getting a force from it. It's just
No,
not
you're
directly in.
It's impossible. Can't. I
Okay,
can't.
so
if you just
can I give
me
an
on
example of this?
Sorry.
If
Dude,
the Earth
in
was
his
not
own
rotating,
definition, it says it acts upon something. His own
This is
definition says
not
it.
real.
If it wasn't real, it would have acted upon something.
Not
the,
a real
You guys are
force.
getting
if the
things
Earth
mixed.
was not rotating, excuse me, hold on 1 second.
conversation.
Wait, yeah,
Move
right.
on.
If the Earth was not rotating, hurricanes would not exist, right? But we can measure hurricanes. We can make predictions about
That is
hurricanes.
begging the question.
It's caused by the Coriolis force. It's caused by the Coriolis force, and it exists because we're in a rotating reference frame.
You can't prove that.
Stop it.
It's ridiculous. Hurricanes don't are not just hurricanes.
You
Anything rotating is a
prove
mouse.
it. You
You
can't prove
can't
it.
prove that.
What is
No, you
this?
can't. And
2015?
nothing can prove it either. So
All
you'd
right, it's
have to
audio
stop the
chaos.
Earth from spinning
It is.
or rotate it in a different direction.
It's not audio chaos until Elbow starts speaking.
You're right.
Idea.
What is this?
It's so
2015?
Come on,
Let's
just
all
change
settle
something.
down, guys.
You can't handle it, so just move on.
It's a chocolate ice cream.
Vortexes are caused by high and low systems. That has nothing to do with the rotation of Earth. These people that study weather all the time, especially the left lane, that has to know weather patterns when he's flying, should know that and should know that he can't prove that it's Earth rotation causing it because he can't manipulate the Earth's rotation. Can't even prove that the Earth is rotating in the first place.
Well, I mean, you can limit your understanding if you'd like, but I don't.
It doesn't sound like I don't understand. I can create a vortex in a stationary object. Can't you? Maybe it's you that don't understand. And especially since you have to say that because clearly I do understand. Well, moving on. It's just a waste of time. It's like everyone's a troll. Like, why do y'all troll on these things? You know you can't prove them.
And
also, too, the whole thing about hurricanes rotating a certain way, they've been recorded as rotating always in every place of the,
That's not true.
Earth. So
if it's north of the equator, it rotates one direction. If it's south of the equator, it rotates the opposite direction.
Story.
Measured and
They,
it's gone the
they
other
both
way.
take different ways within themselves.
It dissipates when that starts happening. It just dies.
The thing is, you have a storm on Jupiter or Saturn or something where it's going in the wrong direction for the rotation for what Coriolis dictates that it should be going.
Yeah, but I'm talking about on Earth where it goes the correct direction. There's other phenomena that are explained that will explain that, right?
Hold on, man. Let him finish his sentence. I want to obviously respond to that.
Go ahead, revert.
But there's places. But there's a place in your heliocentric model where it's happening the opposite way. It's happening opposite for the direction of the rotation that it should be happening.
Where? Yeah, where?
I think it's Jupiter. Jupiter, Saturn, I could find it, but it's happening in your heliocentric model. Let's just go with it is happening, and we'll figure it out later if it is or isn't. What would you say if it was happening?
I would
you would
say
have
that
to say, oh, it doesn't. I guess the planet spin doesn't dictate the direction of the Coriolis effect will go.
But that's not what I'm arguing. Obviously, I'm not aware of the happenings on Jupiter. I mean, obviously, there's a lot of different variables that are different than on Earth. So I have no idea. I know someone can explain it. I'm sure there's an explanation somewhere, whether it's on the flat Earth side or the globe Earth side or whatever, right?
Sure, but Coriolis doesn't dictate the. Just for the record, though, if this is happening on Jupiter or Saturn or wherever, Coriolis doesn't dictate what direction the spin, the deflection will be.
I have no idea about that. I know that on Earth that does happen, though.
I know, but let's say we found it on another planet in your heliocentric model going the wrong direction as what it should for the Coriolis effect and the planet's rotation. We would have to come to the conclusion that the Coriolis effect doesn't dictate which way.
No, that's not what we would conclude. We would look at the other forces involved first because we understand Coriolis very well.
If you can have it happening opposite, obviously Coriolis doesn't dictate because it's happening opposite of what Coriolis dictates. So
Coriolis can still be doing its thing. There can be other forces involved that we're not aware of or that are not mentioned and as part of the variables because of the size or the makeup of the planet. There's several factors that could cause it, right?
Yeah. So the conclusion is Coriolis doesn't. Go ahead.
So that's not a conclusion.
Dark. If that's the case,
somebody else was trying to go. I didn't stop, so you could go again. I mean, you didn't hear somebody trying to talk at the same time as me, whoever that was. Go ahead.
I had you and him.
Dude, go ahead, Jeremy. If I gotta mute you, Elijah, you have me blocked still, so I'm just letting you know.
Go ahead, Jeremy.
I said no. I answered your question.
Yeah, I'm just letting you know if you get if you get modded or something, it's going to be a tough mod because I can't just do it like a simple thing with you.
If you want, you can make me mod and I'll gladly mute Elijah.
Yeah, you can make me mod. I'll mute him too.
I'll ban all you.
How about we do a one versus one? Guys, hold on. How about we do a 1 versus 1? Because this is the worst I've ever heard about Coriolis. This is a cluster, you know what? How about a 1v1?
All right, Bear versus whoever's the Glober.
Well, listen, I wanted to hear Jeremy said that there's the conclusion is ... I was going to respond to that because I think I know where he's going, but I'd like to hear what he says first.
Yeah, the conclusion is that the Coriolis effect in the heliocentric model does not dictate which way storms rotate.
How did you draw that conclusion?
Because we have it happening the opposite direction as what it should be happening according to the Coriolis effect.
You're talking about on Jupiter, right?
Yes.
Do you know what other forces
Jupiter or Saturn?
Do you know what other forces may be involved on Jupiter that aren't as
there could be
well defined on Earth or as powerful?
There could be other things happening, sure, but obviously Coriolis isn't the end all be all of which way storms rotate.
I don't think anyone said that. I said
it's happening in the opposite direction as what it should be according to the Coriolis effect.
The point is that on Earth, right, we can make predictions with it because we understand how it behaves, and it happens to behave where above the equator it does one thing, below the equator it does another thing. The balance of forces is different than what it might be on another planet. And the Coriolis is still going to be affecting it on that other planet, but obviously there's other forces that can counteract it or can just be stronger than they are as they're present on Earth, right? What have you. I don't have the data. I can't comment on it, but that would be the first thing I would look at is what are the difference in the balance of forces? Then how do they differ than on Earth?
They say it's because it's a super high pressure thing. It's irrelevant on what other forces or what else might be there. If you're saying, this thing has to spin because we're spinning in this direction, the Coriolis force says this, that's not what's happening elsewhere in your own model.
I didn't say that, though. I said that we can make predictions based off of our understanding of how it behaves, and it happens to behave the way that that we can use it above the equator. It does one thing. Below the equator, it does the other thing. On Earth, specifically Earth, not another planet.
All right, which way is the deflection for hurricanes which way is the Coriolis deviation for hurricanes in the northern hemisphere?
Pretty sure it's counterclockwise, right?
Okay, which way do which way is the deviation for Foucault pendulums in the northern hemisphere?
I mean, it's going to be the same direction. Whichever direction it is, it's one way.
Not the same direction.
You should have let him finish.
Well, it's gonna be opposite of however it is in the south, right?
No, it's not. It's the same. It's the same direction as it's the opposite direction of the hurricanes.
Oh, because the hurricane is operating from the inside out. Yeah. Okay, that makes sense.
Oh, it's an inside out hurricane?
Well, yeah, because the force is generated from the middle and the
Foucault pendulum's outside in?
Yeah, absolutely, because it's swinging, right? It's like an object. It's not generated from the inside, from the eye of the hurricane, right?
The deviation is supposed to happen in the same direction. Maybe we'll talk about the Foucault pendulum particles next, but the deviation, according to the Coriolis effect, is supposed to happen in the same direction in the same hemisphere.
So you're saying that scientists just fucked that up? Is that what you're saying?
I'm just letting you know they in the northern hemisphere, hurricanes and Foucault pendulums don't deviate in the same direction.
Yeah, and I gave you the explanation that I came up with. It was probably a very inaccurate way to put it, but I mean, a hurricane generates its power from the inside out, right? And I feel like as a solid object, right, the Coriolis force is going to behave differently on something that's solid. Like it's not being affected by
point.
Please let him finish, Elijah.
No, the point is that they're going to be opposite. Yeah. The point is that they would be opposite. That would be my prediction, and that would, whether or not they go the same direction. I'm just telling you, I think that's what the explanation is something to do with the fact that the eye of the hurricane is pushing everything outward, or it's affecting it in just in the inverse direction, I guess. I'm not an expert on hurricanes or solid objects swinging and deflecting, but that's my layperson understanding.
So the deviation is happening in the different directions in the same hemisphere, which is not what Coriolis says should be happening.
Well, guess what? If we go south of the equator, the same thing's going to happen. They're both going to still be opposite, right? So they're measurable. I mean, what's the difference?
No, it's not right in the north or the south. Yes, correct.
Right. It would be inverse. It would just be the opposite, right? Whether or not it's happening one way or the other, the point is that we can still use it to make predictions.
Yes, it's incorrect in both hemispheres. Yes.
If you want to call it incorrect, fine.
Well, I mean, it's deviations happening in different directions. One's going clockwise, the other one's going counterclockwise.
Can we use it to make predictions that are accurate?
The prediction for the Coriolis effect is things are going to deviate in one direction in the northern hemisphere and in the other direction in the southern hemisphere.
Yeah, and we can determine our latitude by using it.
You've already made a prediction on which way the Coriolis deviation is going to happen on Earth, and it's happening opposite in the same hemisphere for the Foucault pendulum and the hurricane.
It doesn't matter. Can you use them independently to make predictions?
You're just saying it doesn't matter that your prediction. You've already made the prediction.
You're trying to draw a comparison where there doesn't need to be.
You're not getting it. You're not getting it. You've already made the prediction on which way the deviation is going to happen and which hemisphere, right? That prediction's already been made, right?
Listen, I'm not saying that it's one way or the other. I'm saying that they're the opposite. Whichever direction it spins, right? It spins the opposite in the southern hemisphere than it does in the northern hemisphere. You don't need to try and walk me into the corner of a wall. The point is that you can use it to make accurate predictions. Independent.
The prediction's already been made, dude. The prediction has been made on which way things are going to deviate in which hemisphere on the globe.
Yes, but there's magnitude based on where your latitude is.
Okay, and we have it happening in different directions in the same hemisphere.
Wrong. You're drawing a comparison between hurricanes and a pendulum, bro.
Yes, the pendulum deviates one way, counterclockwise, and the hurricane goes clockwise.
I couldn't give two shits. My point is that you can use them independently to make predictions.
This isn't the argument.
Wait, I don't give a shit.
If he doesn't care,
the prediction's already been made.
Yes, and you can measure the magnitude. The prediction's already been
made on which way things are going to deviate.
So listen, Jeremy, what's your point, bro? Are you saying that science is all wrong? Are you saying that science is wrong? No, tell me your point.
You already told me you don't care. You already told me you don't care about it. You don't care that it's going in different directions. So,
well, why don't you convince me that you have a point?
Obviously, this combo isn't for you.
Yeah, because I'm convinced you don't have a point. That's why I don't care. Give me your point and change my mind.
How about you explain how it could be going in different directions if the Earth is just spinning in one direction? They're in the same hemisphere. Go ahead, Pete.
I just said,
and that will explain it. But
no, I want
Jeremy
your
don't care. Harris, look at the image, please. Look at the image.
Hold on, let Jeremy and this guy finish, guys, because if we do this again, it's going to be a cluster. You know what? Let them finish.
I'll post the help
No,
image,
it's over.
but whatever.
I don't. There's nothing else. This guy. There's nowhere else to go.
So you were just saying things and you had no point. Is that what you're saying? Because sure, whatever the deflection.
You guys predicted which way things are going to deviate in the northern hemisphere, and your prediction failed.
You can say that, but you'd be wrong. That's why I said that I don't care because you don't have a point.
I'm not wrong. The pendulum goes counterclockwise and the hurricanes go clockwise. Not wrong.
So by implication, you're saying that scientists actually predicted it went one direction and went the other, right?
No, scientists predicted which way the deviation is going to happen in the northern hemisphere.
Yes, and you're saying that it happened the opposite and they were fucking wrong. That's what you're saying?
Well, clearly, because the deviation is happening in different directions, clockwise and counterclockwise in the same hemisphere. Yes.
Yes, because when something is rotating and you go from the middle up, you're going to deviate one way, and when you go from the middle down, you're going to deviate the other way, even though the whole thing is rotating the same way. You're changing directions. You're going in 180-degree different directions, so your Coriolis is going to be exactly opposite from each other.
And that's roughly what I was saying.
Are you saying we're viewing something from the bottom up?
No, don't do that.
It has nothing to do with the way we're viewing it. It has to do with the way that the
force is generated.
Yeah, the way the hurricane is moving, whether it's moving north or whether it's moving south. That's a 180-degree difference from each other, even though the ball is rotating the same way on both sides.
I think you misspoke a little bit. It just depends on where it lies on the globe. If it's above the equator, it can be moving south and it would still be rotating the same direction. It can be moving north, it'd still be rotating the same direction. The point is when it hits the equator, then it dissipates because it starts trying to spin the other direction because the force is the opposite in the south.
Isn't this all a moot point? Moot, whatever the right one is. Because you have to assume Earth rotation.
No, you don't.
Why don't you just shut up. Why don't you actually just demonstrate Earth rotation? Then you have no need to start talking about Coriolis till you're blue in the face.
Can you make predictions on flat Earth with the Coriolis force?
I could make predictions. Predictions about the hairs on my nuts. It makes no difference. If the Earth rotating, I should hold on. If the Earth
then bring an argument. Go away. If you don't have an argument, go away.
I haven't finished my sentence. If the Earth is rotating, I ought to be able to demonstrate that independently of any prediction. The same way the opposite is true in another situation, right? So if you keep bringing up predictions, all that demonstrates is that you don't have a foundation to form your point on.
Where'd you get your science degree?
You're going to second and third order things that you can correlate if you wished, right? And then assume your position that you started with. But why would you do that if you had foundation, right? Why would I have to come and bring up some other talking point if I had proof that the Earth was rotating, or if I had proof of such and such? Start at the base and work up. Don't go backwards. It's retarded.
Yeah, listen, you're being stupid. You can make predictions with it accurate on the globe. Okay, simple as that.
Oh, so you don't. So that's a concession then, right? Because
show me your flat Earth predictions.
The English didn't fail your brain. You actually stayed silent enough to let me make my point. So you understand that it's true that if you actually had proof of said thing, in this case Earth rotation, then you wouldn't need to bring up anything else. So the fact that you then bring up something else demonstrates that you don't have the initial.
Okay, then why do hurricanes spin one direction on flat Earth?
With your mouth or not?
Hey, why don't you finish up? You talk forever. Finish up. Make your point.
Want to admit it or not? That's a concession, because if you had proof of Earth rotation, you would just show it directly.
Yeah, I do with successful, accurate predictions. What's your successful, accurate predictions, you fucking idiot?
Not proof.
Why is this allowed, man? Is there a
dude?
Why is this so?
Correlation does not equal causation, dude.
What are your predictions?
At the beginning.
It's a one-sided argument. One side has evidence and systems and methods.
Stop talking, bro. I'm gonna time you out. You understand that?
I just joined.
Please don't swear.
I acknowledge.
Okay, thank you. Please don't swear. Go one at a time. Let's have Elijah and you. Nobody else talk. Okay? Thank you. Go ahead.
Yeah. The globe.
Are you time. I've made my point. I think anyone who was listening understands it. So if
Yes.
if he wants to carry on talking about things that don't relate, that's his problem.
We take a flat
If
Earth
you don't want
model.
to talk, then somebody else will do another 1v1. Otherwise, we're very excited today, and everyone's going to talk at the same time, and we're not going to get nowhere. Who
I'd
else
like
wants
to-
to go 1v1?
No, I'd like to address him, and then he can be silent. That's fine. I'm going to respond to what he said. You have two
Go ahead.
models, right? You can say that the flat Earth model doesn't exist. Whatever you want to say. We don't claim whatever. The point is we can take a globe and we can take something flat and we can make predictions based on those shapes. Whichever predictions come true is the model that we go with. Simple. You understand?
Yeah, I agree with that.
You've
Are you
got
saying
proof, right?
there can't be weather on a flat plane? And in a model of a sphere Earth, you would have curving water. I predict that, but you can't. It doesn't come true. So which model is true again? Like you can have weather on both. Weather is caused by pressure systems. That's why you don't have hurricanes forming in Florida and going towards South Africa or wherever they come from. They all.
I'm sorry. Did you have a point, or like did you have
Earth is a
any
cube
evidence?
then.
Or were you
It
just
doesn't curve,
insulting?
it's a cube then, right?
Yeah. He went
Yeah,
silent.
Rocky, I
Okay,
think you got cut off.
One. Kia and this guy. Go ahead, guys.
Did Rakia come back?
No, he's muted himself, but I think his internet got cut off as he was finishing his point.
Yeah, he probably got a call or something. Let's give him a couple of seconds.
The irony is no one brought up models or opposing models. If you want to bring that up like you did, then why don't you just show curvature?
Yeah, I'm going to bring
Like
the
every
curvature for you, so
time
you can
every time
deny
you
it.
guys do this, you just present the folly and
Yeah, I'll
the
bring it up so you
assumption.
can deny it if you really want.
Is it avoiding? He's avoiding.
I'm not avoiding anything,
We're
dude.
not avoiding anything. We just gave you specific reasons why weather happens on a certain, like it wouldn't matter what the surface is, and to say that it's caused by rotation of the surface, then you would have to manipulate that cause, and you can't. So that is not proof. That's just in theory it works, and you say, aha, right? It doesn't mean it can't work on something that's not rotating due to pressure systems, which is how we know weather systems act anyway. That's where you get your wind, convexity, you can get heat exchange, you get all that on a flat surface. If you can't agree to that, you just should leave and go live your life somewhere, because that's always going to be debated.
But why do they appear to rotate?
Because that's what the weather does.
That's not a reason.
Yes, it is. In that region where these hurricanes, they're just not hurricanes, right? They form as storms. They become tropical storms, larger. They get over the warmer oceans, which creates convexity of vortex. And then depending on the weather patterns and the wind patterns in that area, it just so happens to create the rotation in that direction. Then you jump in and say it's the rotation of Earth. It's ridiculous.
I don't see, the thing is, I disagree with that. I mean, I don't disagree. Well, there obviously is something that is like happening at different latitudes, and it's separated by the equator. And in the globe model, they kind of like have that geometric explanation with their spin forces. In that model. So like you do need something in replace of that, which we do have, and it's not just pressure, because this pressure is not going to, different temperature and pressure changes aren't going to be consistently happening, causing the same vortex on different sides of the equator. There's obviously something happening.
People that live in Oklahoma that don't experience hurricanes, that only experience tornadoes, that pressure doesn't cause it, because I promise you, they'll teach you that it does. But that's why hurricanes develop in certain regions, become tropical storms first. They get into the warmer waters and get more energy. That creates a stronger and stronger vortex, and those wind patterns and pressure patterns create a rotation and a travel speed. The speed is dictated, the direction they travel. They don't go in straight lines or deviate due to Coriolis. They go according to the pressure systems. They can take 90-degree turns.
Well, that's easy. Let's just look that up.
Rotation of Earth or Coriolis.
Let's just look that up and see what science says about it.
Alicia asked
It's how
me
the
for
winds
photos.
rotate
So,
around the low and high pressure systems.
yeah.
That's literally why they say it's happening on another. That's literally why they say it's happening on another planet, Jupiter or Saturn or whatever it is because of what rock.
Yeah, weather are extremely complicated phenomena, and they are also electromagnetic in nature. Like people think it's just like, oh, you mix gas together and heat it up and you get a vortex. Like, no, just as thunderstorms and rainstorms are knowingly due to charge separation within thunderheads when rain occurs. When rain is being absorbed, there is one polarity on the cloud and it acts as a vacuum. When rain is being expelled, there's a discharge which flips the polarity and it acts as a pump. This is the mechanic.
Great
This is
point.
the mechanic of thunderheads, and this there's also in the same way a very important, crucial one might say, electromagnetic component to all storms, and hurricanes are no exemption to this. And in the north, right, the rotation is different from the south, and it's flipped about the equator because in terms of Earth's electromagnetic field, the equator is actually the equator line in any electromagnetic system with the dipole in the center. That's what it is. It's a flipping of the polarity or the direction at which the field lines curve away. So it's expected that that behavior would be seen in an electromagnetic system, which a thunderstorm or a hurricane in this case is.
Okay, can we stay with reality now? I posted in the chat. I typed in what causes the curving path of hurricanes. First thing pops up: Coriolis effect.
Yeah, that's all right. Alicia, Elisha, or Rakia. Rakia wanted to see our water curving. That was 4 minutes ago now. So there you go. You can explain it if you'd like, but I mean, you're just going to say no.
Let me look. I would love to explain. I can't wait to see this. Where's water curving again?
You'll see red letters. It says 90.
So you're showing left to right Earth curve. So you're saying left to right, that's Earth curve, water curving.
Well, that's what you asked for. You asked for the horizon, right? Like you wanted to see water.
Yeah, water curving, actual physical water curving, not something caused by a lens effect or whatever you say it's caused by. I'm talking about the cause of the water curving being Earth curve. Are you trolling? Because this is a waste of time.
Well, would you like me to explain?
Hold on. First of all, real quick, guys, hold on a second. Real quick. First of all, you showed the only part of your globe that's actually flat, the horizon. That sits on a plane. That's the only flat part.
So you said hold on to interrupt my explanation. Yeah, I was going to explain it. So the first photo, it says 90, right? That is the reticule at 90 degrees at where you guys said that the horizon always rises to. That reticule in the middle is in fact showing that the water is not rising to it. Hence, it's curving away from it, right? If you go to the next photo, it's 270. What he did is he flipped the lens upside down. Hold on, excuse me. I'm still explaining. No, you can stop until I'm done. No, I am explaining the difference in the photos. It's important. You can wait your turn. The second photo, quiet.
Just hold.
No, wait a second, and you can speak when you're done. When I'm done, okay? The next photo says 270 degrees. What he did is he flipped the lens entirely upside down to show that the water is actually going away from it at the same rate. The final photo shows where it's actually sitting, which is at 269, 52 minutes and 10 arc seconds, right? So that's showing that it's below 270. So what's your explanation for the water curvature?
That's not water curvature. That's a lens effect, probably. And the water being below the crosshair in that one photo doesn't mean that it's dropping away. It means that's the effect that the optical view is given through that optic. Because on another time, the water could appear above the crosshair. Have you ever seen it?
Okay, I'll explain again since you weren't listening when I wasted my breath a minute ago. The first photo.
You don't need to repeat it verbatim. Like
no, I do.
He's actually replying to you. No,
he's actually not listening. The first lens is right side up. The lens is right side up. Excuse me. I'm going to explain it again. I'll be brief, but be quiet for a moment. Excuse me. Excuse me. Be quiet for a moment.
Yeah, why is it allowed that he's being constantly interrupted, guys? Y'all shut the fuck up and talk.
He wasn't listening. So
you hear this? Hey, Jesus Christ is Lord. Rakia was first. Stop hive mind over speaking him. Sorry.
Quiet. Okay, no, Rakia, you can wait your turn. 1 second, please.
No, I'm not
the very first image.
I asked you a question.
No, I just complimented him, Rakia. Go ahead. He's not going to control what happens here. No, buddy. You're not going to repeat it again. You're going to let somebody answer. Go ahead, Rakia.
Well, I answered and said that I've taken views like this, and other Glovers have taken them, and the water appears lower than the crosshair most of the time. I would agree with that, and y'all call that drop or Earth curve. We've gone through this for 8 years now. It's not drop or earth curve. It's just the effect of the optics. Because on different days, you can have that water appear above the crosshair, which would mean it's not dropping, which would mean it was rising, which would prove concave earth. And on other days, it would be equal or have risen to the crosshair, which would mean prove to a flat earth. I don't think it's measuring anything. This has been debated for 8 years, and this guy brings it up like it's the first time, and it's water earth curve, right? Sphere earth causing the water to appear curving. And he's showing also a left to right curvature, which we've been told for years that's not possible to see.
Okay, let's let him respond now.
We actually just went over a paper last night that showed that I think they measured 147 lakes and only 10% of them measured convexity. The other 120 something were all measured concave and flat.
Yep. Shout out to concave earth.
All right, I'll be brief.
Yeah, that'll happen at low level observations. The point about this is
can we let Spin respond because he got muted? In all fairness, let's let him respond.
Thank you.
Okay.
The first image is taken with the lens right side up. The second image, they flip the lens upside down to cancel out the effect that you said Globers never account for. That's the answer to your question.
Altitude of the observer.
What's the altitude of the observer? That's a good question. I can get that for you. But what's his explanation for the fact that he cleared out his error by flipping it upside down, and it shows the exact same height above the water when the lens is upside down?
Is he looking for the same optic over the same distance?
Yes, he flipped it upside down to offset any potential error would be offset. It would be obvious. It would be apparent. It would be optical.
I'm not talking about the error. I'm talking about the optical effect by looking through the same optic through the same distance.
Would you agree that if there was an issue with the level line that's there in the center of the screen, that they would be at different heights above the water? Would you agree?
Yes, I'm not saying there's a error margin causing that apparent drop. I'm saying it's an optic.
Would you agree that if there was an issue with the lens not being level, that it would be obvious and you would be able to see it optically? Okay, then what's your explanation for that not showing up?
Because that's what an optical phenomenon does. Sometimes it shows it above the crosshair and sometimes below and sometimes even. You don't even know that's where the sky meets the ground because in apparent position, it changes daily or with the weather patterns, with the conditions of the day. It doesn't matter if the tool is set up level or not. If the mirage or optical illusions are causing the water to appear below or the sky to be mirrored onto the water, then you're going to see it whether the lens is upside down, sideways, or whatever.
Now, you're talking about low-level observations, Rakia. This is obviously at high altitude, and you're not going to get those inverted observations from high altitude.
Says who?
It says facts.
So boats going over. So when you're viewing, okay, fair enough. So when you're viewing boats go over the curve of the earth and being obstructed bottom up from the beach, you say that's not true? Yeah.
I'm not talking anything about watching boats go over the horizon. Why are you talking about that for?
It's low level, so it's not accurate, right? So it could be something else.
We're not talking about that, though. We could talk about that, but that's not what we're talking about, though.
I think everybody's mentioned the point. Phenomena. I'm talking about known optical phenomena that anybody with a grain of salt can go out and spend a weekend and view. It's just come down to New Orleans because it happens all the time. I've shown you over and over again how the bridge.
Not at high altitude.
The elevation was 22 meters.
The optical phenomena can cause the bridge to appear underwater, but yet you can drive over it left lane. And you say if the low level causes that and it doesn't happen at high levels, I agree that the different phenomena change with altitude, but it doesn't mean that optical phenomena stop happening just because you went up at a higher altitude. That would be ridiculous because you see further. And the distance is an effect also, or a cause of the effect.
Rocky, real quick, bro. Like, I just want to clarify for the guy that you're arguing against, because he's like I think he's hung up on your use of the word optics, thinking that you're speaking only of an optical device like a camera or theodolite or lens. When people say optics, they mean like the effects of in the optical regime, such as, for example, atmospheric refraction and distortion. Skunk Bay is like one of the clearest, most widely used examples of this phenomenon. That you have a camera on the side of a building sitting above a bay, some decent distance, and you can see all the way across the bay. And throughout the day, the water level appears to go above and below the crosshair of the device, the center line of the device.
It's another low-level observation.
That's right.
He's up on a mountaintop. It's not a low level observation. Left lane is just wrong again.
Yeah, he said this is 20 meters high, and you acting as if like this only happens right above the surface of the water, but once you go 10 feet, 20 feet, 30 feet, it stops. Completely not true. That would be to
It's
say
20
that,
to 60 feet.
This is 22 meters high.
yeah, that doesn't matter, bro. You act
Oh, it
as
does
if there's
matter.
not you act as if there's not temperature gradients everywhere.
I did not act as if there's not. I said that just like Left Lane was saying, the higher you go, the less refractive effects will take place.
Less doesn't mean never happens.
I didn't say that. So quit saying stupid things.
Left lane did.
It happens to a lesser degree. That's what Left Lane said also.
Right. So
Yeah, when you increase the distance, things change too. If you go up higher and do the same distance, the effects get less and less. But when you go up higher and look over a longer distance, then you're bringing in another factor, another condition that affects your optics. And if you say it doesn't change it, then you're the one that's just wrong.
No, Rocky, you're skipping a point. You're skipping a point, bro. Just wait a second. What they're basically the difference between these two positions is in the glow paradigm, they claim that on any given day, refraction is not actually causing us to see a curve. We're just actually seeing the true shape. And sometimes refraction will cause it to appear to rise up above the crosshairs instead of below. So the glow position is that the reason that it's a little bit below the crosshair by default is because of physical curvature, not optics. Our position is that warmer air is always closer to the bottom. Cooler air is always closer to the top unless some deviation's happening. That's the standard setup. That's the standard condition. And because it's always curving like that, you're going to see it look like it's curving down. So
which air is colder or warmer air is more dense?
Colder air.
Which one is more dense? Colder air is more dense, right? Yeah, which one would cause the more effect? More dense air or less dense?
Yeah, you're talking about an inversion, which is a rare phenomenon that usually happens over a very hot surface, like in the desert. You see the mirage. The atmosphere gets cooler as you go up, but density does not follow that temperature gradient.
Yeah, you're not helping your case, bro.
Inverse of that.
Yeah, you're not helping your case. Refraction normally causes things to appear higher than they actually are, and so that would make your point even worse, right? Because
when I have physical evidence, right, at different altitudes, the effects I would agree are easily obtained at lower altitude. That's why boats going over the curve.
Yeah, I can do that for you.
Observer is bullshit that y'all used to just go to every day. Now y'all go to different stuff. You got to gain altitude, and now y'all are trying to say that the effects aren't noticeable. That's just bullshit again because you're looking longer. You're also looking down to the ground. Like, even if you're up on a tall mountain and you're looking down where the sky meets the ground or the bottom of a mountain, you're still looking through a layer of atmosphere, probably even a longer distance that if you viewed a boat going over the curve from the beach would be. And you're saying it doesn't show effects. Yes, it does. Optical phenomena, optical illusions, your brain being fooled by long distance observations happen every day, every time you look, even on short observations.
Yeah, I'll get something else for you to know. Yeah, give me a second.
Important when you go above a certain height. The higher you go, the higher you go above the ground. So that means that the further the ground has to come up to meet the midpoint, the vanishing point, right? That's the reason why planes look as if they go really far down as they go toward the horizon, and stuff on the ground doesn't look like it comes up much at all because you're really close to the ground, you're really far from the sky. But as you go up, as you get higher above the surface, what ends up happening is that you have to be able to see further in a horizontal direction, like further out, in order for the ground to be able to come up far enough. And you actually end up running into the limit of your vision distance through the opacity of the atmosphere before you reach the distance of that is required for the ground to be able to come up.
Exactly, which changes daily, hourly, by the second.
Which is why as you go really high, like in weather balloons and stuff, you appear to see like the ground to drop even more, but it's not that it's a clear horizon. What actually happens is as your vision disappears into the opacity of the atmosphere, so you're limited by your viewing distance, you're not able to achieve a far enough distance away for the ground to be able to come up all the way. It's not that the ground's curving down, it's just not optically able to come up because you can't see far enough. Because the
I got some more evidence. We got some more evidence for you to say not onto. Okay, this was taken in Ibiza. The elevation above the surface, I'll grab that for you in a minute, but I'm going to explain the what you're seeing here, this observation. Do you see in the live stream text, Rakia, and Jesus Christ is Lord?
Do I see in the hold on, I'm in my car, give me one sec.
Oh, I'm sorry, I thought you were
He's showing
don't do it if you're
the
driving.
green table and red line, the squash view of that green table that curves, and saying it's the Earth curving, not because the table is curving, the Earth must be curved.
No, that's
Bullshit
not.
from 10 years ago.
No, that's not what I'm saying. You don't understand the observation,
That's
so
not
I
your
can explain it.
post?
Yeah, it is. I can explain the observation.
I see the green table curving as you squish the image. You act like we didn't go over this 10 years ago, bro. You're just late to the party.
It doesn't matter if you went over it 10 years ago or 3 decades ago. You don't understand the observation, so I'll explain it. Would you like me to explain it?
You don't understand reality when you say we just not on your cause for things being obstructed and like appearing to curve when we went over it clearly. Yeah, it's the green table thing that's curving. The flat table that curves when he squishes the image and sees that table. Yeah.
Okay, so you don't want me to explain it. Well, there's the evidence.
We're wasting time.
Picture with the table.
So what you're
Show the
looking at
picture
here
with the table or without the table?
So what you're looking at here is an observation shown between two copper pipes that have known straight edges. You can see the horizon through them. All right, I'm looking at the second image where it's lined up against the horizon. They're known straight edges, right? There's nothing to do with a level table or a straight table. The table doesn't even come into play. It's just holding the measurement apparatus. The reason that this is such a good experiment is because, like I said, these are known straight edges, right? To a degree that we can make an observation, right? And we can hold it up. It's straight. What we do is we compress that image and the third image, right? So the second image is the elongated version. When we compress it or squeeze it really, really tight together, that is going to accentuate the features. Like the upward and downward features of the photograph are going to become more apparent because our eyes are able to see them easier. The straight edges in the photograph in the third one are still straight. However, there is a very noticeable curve in the background against those straight edges. And my question is, why?
Yeah, so it could be due to, first of all, we don't know.
Can I respond to this? All right.
Well, maybe we should both.
I mean, I got a banging response for this, so I do know. Mine starts with I do know. So I mean, do you want to hear Jeremy your thing?
Well, there's two. Well, I'm saying there's multiple potential explanations. We don't know which one is actually happening. Right? We can't confirm with objective knowledge which one is the cause, but there are multiple options. Is my point.
Well, Jesus doesn't know, but Jeremy knows.
Just let me finish it, and Jeremy can tell you the difference.
I know what's going on here. So go
But
ahead,
in order
finish it up. Go ahead.
Yeah, in order for this to be like what you want it to be, right? What you would need to do is you would need to take the aperture size of this camera, which is whatever angular width, right? So you got an angular width. You would need to take your elevation, right? And you would need to, based on your elevation, what the drop should be to the horizon, take that into account to see what kind of curvature you're supposed to see. And then in this third picture, the very last one, how you see it starts like out on the right side, pretty much horizontally, and it appears to drop off to the left. You would need to draw a triangle with a tangent line across that horizontal part on the right, see how much of an angle there is between that point and the leftmost point, and extrapolate that into the full 360 degrees around you based on the aperture size of the camera to see if it matches the predicted drop you'd see at this elevation. If it doesn't, then your whole point's moot anyway, and no one's done that.
I don't even understand the picture. Like, it's not even supposed to be like curved like that on the globe. You see a circle around you. It's weird.
It's further accentuated because
Can I just
it's squeezed.
respond to that, sir?
Yeah, go ahead, Jeremy.
Yeah, you're actually referencing the one part that's physically tangible. It's geometrically flat. The horizon, the circle around you. That's actually geometrically on a plane. It sits on a plane on a globe. And what you have going on here is you're above a circle. right? It's a circle around you, so you're above a circle. And if you can, anyone that has a hula hoop can demonstrate this. When you're level with the circle, which is on a plane, which is the same thing the horizon is on a globe. It's sitting on a plane. And when you get above it, if you're eye level with the hula hoop, it'll look like a straight line. But once you go up above, yes, it looks like it's curving. However, we know that that's actually just geometrically a flat part. So you're literally referencing the only flat part on a globe to try to show them curvature. It's crazy. It's very
No,
strange.
the horizon is not flat. It is a disc around you, right? But it falls away from you at certain distances, and it can be further accentuated when you squeeze a photograph, such that I've done here in the third one. And your answer is that that's not happening, but it's obviously happening. And
you didn't squeeze that photograph. You didn't squeeze that photograph.
It doesn't matter who squeezed it. That's the genetic fallacy. I asked you to explain why there's a curve.
You said
there.
you did it.
We did it.
Why is it not symmetrical? Hold on. Why is it not symmetrical, bro? Like, why does the right side of the midpoint come up and be like flat, and then the left side of the midpoint just continuously curve down the whole time? That third
level.
That's an irrelevant question. The right question. I'll explain why it's irrelevant. I'll explain why it's irrelevant. Do you want me to answer?
Is this what Globers are using, dude? Distorted images that don't even match the globe?
This is a military troll, it seems like. I would be willing to bet this.
Okay, so you don't want me to answer. You're just going to keep talking.
It wouldn't happen on either model, bro. It's just a distorted image. I don't know what's wrong.
Except that it does happen on the globe model as shown here in the third photograph.
No, that does not, dude. You do not see that kind of fucking weird ass fucking horizon changing, like curving like that on a globe.
Yes, you do. When you squeeze the photograph, that's what you see.
It's totally asymmetrical, bro. Like, it would have to be symmetrical.
That is an irrelevant point. The point is that there are straight edges.
Irrelevant.
It is, and I'm going to explain why if you'll shut your mouth for a second. The straight edges in the photograph, be quiet. The photograph shows straight edges that are still straight. However, the horizon in the background is not straight. Do you see why it's irrelevant now?
How does that have anything to do with symmetry, bro? Do you understand that a circle is symmetrical? If you're standing on any point and you're level and you look out at a circle, if it's going to fall away, it has to fall away symmetrically from the midpoint. That does not happen in this photo. Therefore, it's not based on a cause of curvature.
That's a great point. We can address that after you explain why the curve is visible in the background.
I can explain.
Because you're above. I just explained it to you. I literally just explained it to you. That is the part that's geometrically, that's on a plane. Ironically, the part you're trying to show is curving, but it's just a circle around you on a plane.
That falls away from you at certain distances.
There's a couple things that can be happening in the image. Like neither of them are should happen. Like that's just not what should happen on the globe. Either way, this has to do with optics. So either that table's not straight. So part of it's a little bit lower, and on the lens it's causing that to look like that on one side, and you guys put it close to each other to make it look like the horizon is curved, but the horizon doesn't curve on either model at that
except that it does, bro. And you can see it here in the photograph.
No, it does. You have a symmetrical fucking line around you on the globe when you're standing on
that falls away from you at certain distances. What's wrong with you? Explain why there's a curve then. All you said was that doesn't happen, and I'm showing that it happens, and you're just saying no.
Forwards, when you go higher.
I told you why.
Jeremy, I'll address your point, but QE keeps interjecting. The reason that your point is wrong is because it's not on a plane. It's a surrounding circle. You're right about that, but it falls away from you at a certain distance. It begins to fall away from you. It's not on a plane, as I showed in the previous demonstration.
Do any other Globers agree with this image?
Yes.
You're not referencing that part though.
I don't know. They can speak for themselves. I'm not.
You're not referencing that part though. You're only referencing the. You guys hear me?
Yeah, it was breaking up.
No, you're chopping.
You can hear me now. You're not referencing the part from you to the circle. You're just referencing the outer circle in this curvy table picture. So
and real quick, just to dispel this thing about it being caused by Earth.
That's all. That's what you're referencing. Hold on, real quick, man. Real quick, Piezo. You're only referencing a circle on a plane in this picture.
You cut out halfway. The first half of what you said. The first half of what you said was cut off, Jeremy. Can you say it again?
Okay, can you hear me now?
I think so.
Can you hear me now?
It's choppy.
Okay. All you're referencing in this picture is a circle on a flat.
Do you want to let him speak real quick, Jeremy, and then you can circle back?
Hey, I'm literally outside now. Oh,
okay. All right. Go ahead.
You're referencing a circle. You're referencing a circle on a flat plane in this picture. That's all you have is a circle on a flat plane. Even in your globe. Even on the globe.
Not in the globe.
A circle on a flat plane. That's all you have here. Yes, on a globe. It is a circle on a flat plane. The outer edge of the horizon, the circle around you, the outer edge, the horizon part, that is on a plane, even on a globe. That is
You're wrong.
planar, a planar circle. I am 100% right. That is absolutely how the horizon and the globe works. 100%
It's not, it's not, because the horizon falls away from you at certain distances, as I continue to say.
But check this out, bro. Like this causal.
It's still on a plane.
We need to address the causal claim here. Like then it's pretty obvious that the causal claim is nonsense. So check it out. We see apparent curvature in the photo. Cool. Everybody agrees. Now, you say the cause of the apparent curvature is a physical Earth curve. In order for that to be true, the properties of the Earth curve have to be reflected in the photo that claims it's being caused by that curve. What do we see in the photo? Well, we see in the photo that this curve is not symmetrical at all about the midpoint, not even close to symmetrical. It's almost level and flat as it goes up on the right, and it's totally tapered off the entire time to the left. If it were caused by Earth curve, it would necessarily be symmetrical about the midpoint. Since it is not symmetrical about the midpoint, therefore it does not follow that it is caused by Earth curve. So what you have here is an apparent curve. You have not demonstrated whatsoever that it's caused as physical curvature.
Yeah, but on the globe, you would have to be so high in altitude to see that kind of curvature. Like even like if we saw symmetrical curvature here, it would have to be like 200,000 feet up to see something like that on the globe.
Notice how his rebuttal to all of that logic
Well, I
was.
didn't get a chance to. I didn't get a chance to elaborate because QE wanted to make a point right behind you, so I let him make his point. Would you like me to tell you why you're wrong?
So explain to me. Yeah, I want you to explain why curvature about a uniform curvature about a uniform sphere. Yeah, I want to know how curvature about a uniform sphere, at least locally uniform, because it would be uniform with respect to your vantage point wherever you are. How curvature about a uniform sphere would not have to be symmetrical about the midpoint.
Okay, the curve is symmetrical. What you're seeing here is a camera that's tilted slightly. Simple. Next question.
Now there's non-symmetrical like photography.
I mean, he didn't. He didn't level the camera. The point of the photograph had nothing. That had nothing to do with symmetry. The point of the photograph was to show that there's curve behind known straight edges. Simple as that. He did not level his camera. He took it. He eyeballed it. Right.
How do you know
the table has the same amount of curvature as the horizon? Because
again, you're focusing on the wrong thing.
No, bro. We're focused on the cause of what appears to make the curved table and the curved horizon. They're at the same rate. So why would a smaller table, like a smaller width, appear to curve at the same rate as the horizon, which is even further away? It's a weird phenomenon why you didn't post the table curving. So whatever
he did not control for that.
Whatever caused the flat table, the table that's not curving, to appear to curve in the photo is the same reason that the flat horizon that doesn't curve appears to curve in the same photo.
Bro, I mean, it's kind of irrelevant for why this is like.
Why don't Globbers want to tell the shit up?
Here's the steel man of the globe, though. Here's the steel man of the globe is that the outer edge of the horizon, the outer circle around you, that part on a globe lies on a plane. I could if we had someone that had Blender or something, we could show you that if you don't believe it. But that is how it works. The horizon is a circle on a plane. If you had a giant hula hoop, you could just rest it on the ground where the horizon is, and it'd be a circle around you. The hula hoop would be flat, and the horizon would be it would touch your horizon and be a circle around you.
I want to steel man what you said.
What's also funny, bro, is if
I'm steel manning
I know.
So
are you saying any? Jeremy, is it the same as you saying that? Correct me if I'm wrong. Are you saying that the horizon rises to eye level?
No, no, dude. How'd you get what I said out of that, bro? That's crazy.
Well, eye level would be like on a horizontal plane, right?
Who said eye level?
I did, because it sounds like that's what you're saying. You're just saying it.
I thought you were going to steel man what I said.
What you're saying is that there is a plane on the globe. There's a horizontal plane, and that's defined by the horizon that's always lying on that horizontal plane.
No, didn't say that either. You are terrible at steel manning people, sir.
Dude, look at real quick. If everyone would
you said on a globe that it's a horizontal. The horizon is always on a horizontal plane. Did you not?
I didn't mention horizontal. I said it is on a plane. Yes, I didn't say horizontal. It's probably horizontal.
Okay, maybe I misunderstood. I think I added that. You're right.
Me and Jeremy's talked about this.
The horizon on a globe. Hold on. The horizon on a globe, the outer circle, that lies within a plane. You could set a hula hoop. You could have a hula hoop, set it on the horizon. The hula hoop's flat. It's a flat circle, but it would still set. You could set it on the horizon if you had a big enough hula hoop. It's on a flat plane. That outer edge is geometrically flat, even on a globe.
Is it your position that the hula hoop would be doing the same phenomenon and in the right circumstances that a hula hoop would bend like this?
What the fuck?
Because it's not an analogy. If
You can't see it, I don't know. I don't.
Okay, let me
You guys
explain.
me and
Jeremy's talked about this before.
dude. Wait,
Hold on.
I want to hear what Cole says.
Picture though. Like, please look at the picture. Okay, look at all the things that are wrong. Real quick. Look at the table. Look at the table's feet. This table's feet is balancing on a cliff that is not a flat surface. It's all over the place. It's got rocks propped up on the left
The
side.
fact that we're debating this is kind of stupid, honestly.
Yeah, look at the table. Now look at the table. The table has a piece of sheet metal sitting on it. The sheet metal itself is not even perfectly straight.
You're doing what's called a red herring right now. But go ahead.
The red things that are propped up to make the windows for the observation, they're resting on two little sticks or two little pieces of metal that are sitting on top of the sheet metal and resting under them at certain distances away. They're not even the same distance out on each lever arm.
You're doing what's called a red herring. Once again, if you want to continue to talk, you're just saying things that are irrelevant.
Bro, stop interrupting me.
Well, stop saying things that are irrelevant.
The ends of the red pieces are not flat either, so it's resting on a curved surface on the end and then being propped at a different distance away from that on each side. So much of this entire setup is not even symmetrical or level. In order to draw a proper conclusion, you need the actual left side and right side of each of these windows to be perfectly flat and level with respect to the observer pointing out toward the horizon. If either of those are not true, then ultimately either window is going to have an inclination to it because it's not level with respect to the horizon anyway.
They look level.
Many asymmetries in this. This is not even close to scientific. Bro.
Listen, everything you said was a red herring. Everything he said was a. Can I speak, Jeremy? Do you mind if I address what he said?
Go ahead.
Okay, thank you. Everything that you said was a red herring. The point of this photograph, I'll say it again, is we know that those edges are straight that are compared against the background, which is the horizon. The horizon is not straight. The question is why? It has nothing to do with the table, has nothing to do with the table feet, the legs, the tape on the edge of nothing to do with any of that. We know that those edges are straight. When we compress them, those straight edges remain straight. However, when we compress something that's curved, the curve is going to be accentuated, as shown here in your photograph that you took and in the one that I showed a minute. When I say took, I mean you modified it to make it look like this, which is fine. But there's still an apparent curve, right? And the reason is because there's an earth curve. Everything he said was a red herring.
Take a straight line, hey buddy, if you take a straight line and you take another straight line and you lay them parallel to one another, they'll be straight. If you then slightly tilt one of those straight lines compared to the other, you can say, oh, look, one of them is curving away from the other. Well, we know one's a straight line, so the other one must not be straight. In reality, you have two straight lines, one's just tilted. It wasn't a red herring. It was absolutely necessary. In order for this to be what you claim it is, both of those red window slits have to be perfectly level. Otherwise, there's going to be an inclination of the red window with respect to a flat horizon. So check it out. Pretend
they look level though,
that the horizon, hold on. Pretend the horizon was perfectly straight. Just in that we're in a universe where there is a perfectly flat horizon. If you did this same setup in that world, you would still get apparent curve because your red windows are not perfectly leveled. They're angled with respect to that flat horizon.
You're 100% wrong.
Well, not only
but
that,
I'd love you see you do that, but you're wrong. Sorry, Jeremy.
Yeah, so this dude you guys should stop engaging with this guy at this point. He just repeats nuh-uh. Yeah, all he does is says nuh-uh without actually directly engaging. So this guy's actually a disinformation agent, or at the very least, bad faith. You're wasting your time.
Talk, and then I'll answer your stupid argument. Go ahead, Jeremy.
Well, I'm just saying, like, if we were on a flat earth or a globe, like the outer circle of the horizon on a globe would set right on a flat earth. Because like I said, it's on a plane. Even on a globe, the horizon is on a plane. So you could literally set this on the flat earth. It would be the same. Like there is no difference between the picture you're showing and a flat earth. Either way, we're above a circle. We're above a flat circle. in both of the models. So this doesn't even show anything. And past that point, even before I came to that realization, we tore this to pieces. There isn't a straight line in that thing. The red line's not straight. The black lines aren't straight. The table's not, there is no straight line in that thing. When you compress it, every line's curving. There is no straight line in that.
You just said my point in another way, Jeremy.
Yeah, we tore this to shreds, bro. We've been going over this picture we probably went over this picture about, I don't know, 30 times, 20, 30, 40 times maybe. And yeah, there's not a single straight line in that shit.
Okay, I've made my point. If any other Globers want to talk, that's fine.
Despite the fact of there not being a straight line in that whole thing, like I said, even on a globe, it's a circle on a flat plane. On a flat Earth, it's a circle on a flat plane. When you're above a circle and you compress it, yes, it's going to look like you're going to see the curvature there.
Yeah, what he's trying to say is if, like, imagine a basketball and you're real tiny and you're standing on the main top of the basketball. If you lay a ring that's, I don't know, a third the width of the basketball over top to where you're directly in the center of that ring, and that ring is laying down on the basketball. What Jeremy is saying is that would create a flat plane all the way around you to where when you look at that ring from your vantage point, little tiny thing on the main top of the basketball and that ring's around you, when you look at that ring would be basically a flat line going all the way around you.
I know that's what he's trying to say, but I'm saying that he's wrong.
Okay, well,
and I can explain why.
You guys would look at the ring and say, "Oh, look, the ring's curving." You know what I'm saying? From left to right. But
no,
the
we
ring's
wouldn't.
Not curving from left to right.
If we compressed an image of a hula hoop, let's just say the horizon's a hula hoop, and it's a perfectly good hula hoop. It's made out of the strongest structure hula hoop you've ever seen. It has zero flexion. If we compressed an image of that, and we're on basketball Earth, right? And it's around the outer perimeter, and there's no water, whatever. The hula hoop is there. If we compress that image, it's not going to curve like you see in this photograph. It's going to be straight. And that is actually something that I can probably do. I need the time to set it up and to model it, but that would be that would be what my prediction would be.
Okay, cool. My prediction is if you're above a circle and you compress it and you take a picture and then you compress the image, it'll be curving just like this is, because like I said, there is zero difference between flat Earth and globe Earth when it comes to the outer edge of the horizon. They're both circles and they are both on a plane. There is literally no difference between the two of them.
Well, let me ask you this. If you go up higher, right, the horizon goes out further. Would you agree with that?
Yeah.
You can see more of stuff. Okay, so the higher 100%. And higher you go, if you're on a globe, eventually that is going to start to fall away from you on a globe, on a basketball, whatever. It's going to start falling away from you when you get high enough above it. Right.
Okay. Well, now the argument is where the positioning of the horizon. This is different than the picture. So we're off the picture thing and we're on to something else, right?
Well, what my point is that it's no longer on a flat plane when you go up high enough.
Oh no, it's always on a flat plane. It doesn't matter how far away from. No, you could have a ball. You could have a tennis ball, a basketball. It doesn't matter what it is. How you could see the whole ball. You could see half the ball. It's still on it. It's still if you're only referencing the outer circle. That's always on a plane, my man. That's how a globe works with a horizon. That's how balls work with a horizon.
So just imagine if you were on a tennis ball and you started to lift up off of it. You're a little stick man, and eventually you get up and you can look down and you can see the tennis ball. You will notice that it's curving, right? And the horizon would be like the middle. It would be like the equator of the tennis ball. In a perfect world, if you got so far away and you could still see it, your horizon would be the equator on both sides of that tennis ball. It would be a circle, right? It would be a ring around it, right?
Which is a circle on a plane. It's always, right, no matter how high you get up off the globe.
Okay, I think we're talking past each other, but I see what you're saying now. Okay. I agree with you. I agree with what you're saying. But
this would be bad.
No.
Bad evidence.
I agree with what you're saying that it's a ring, right? What I don't agree with is if we're looking out at 90 degrees or at 270 when I showed you and I flipped the lens upside down. If you're looking straight out level, right, you're going to see that curve because it's going to start falling away from you. Your ring, the ring is at equal height all the way around the horizon. I agree with you there. That ring happens to be below eye level is my point, and that's why you have curve.
Yes, you're above a circle. Yes, it's because you're above a circle. No matter how high you get above the globe, if we're 10 feet above the globe, you look out, you set the hula hoop down to match your horizon. It's on a flat plane. It's a circle. You go up 1,000 feet 100,000 feet. You can do the same thing. There's no height you can get above a ball to where that's not the case.
The difference is that the horizon no longer rises to eye level the higher you go. That's the only difference in what you're saying. What you're saying is correct, with the caveat that the higher you go, the horizon falls away from eye level, and that's why there's curve.
Yes, that would happen on a flat Earth too. You're getting higher and higher above the ground.
I mean, I guess if it's a circular disc, there might be effects like that, but there shouldn't be a circular disc in the middle of, anywhere that you do an observation like this.
What circular disc?
I have no idea what your model is. I'm just saying the first thing that I could think of, right? So maybe it's not a circular disc, but the point is if it is a circular disc, then yeah, that might happen if you're standing somewhere close towards the outer edge of it.
If you could see the edge.
Yeah, I'm agreeing.
Yeah, if you get somewhere and see the edge, yeah.
But if everywhere there's an ocean, there's an edge, then that doesn't make a whole lot of sense. If we know that there's land, the further we go into that water, that we hit
everywhere
land.
There's an ocean, there's an edge.
Say this guy got in a motorboat right here and he just started driving through the water. Eventually he's going to hit land, right? Is my thought. I mean, unless he's on the edge of the earth, the flat earth. But just take a random spot, you're likely going to hit land before you get to the edge. Well, that edge was still there. It was still apparent to you, but then you realized, oh, okay, well then there's land here. And now there's a new edge and it's further beyond that because the horizon changes.
No, the edge is as far as you can see. What do you mean?
Yeah. The edge becomes different though, based on your location. Like you're going to chase the horizon and it's always going to go away from you. Right.
Why are we chasing the horizon? I don't know. You lost me multiple times throughout this. I don't know.
Well, I'm saying unless you're on the edge or unless you're near the edge or have a vantage point of the edge, then it's just an optical illusion because you're not actually at the edge.
The edge of your vision. It's the edge of your vision, the circle around you, the horizon.
Yeah, but it's not the edge of the earth.
I never said that.
If it were the edge of the earth, then we would. My point was that I thought you were making this point is that if you were looking out and you saw the edge of Earth, maybe you were talking about vision and I just misunderstood you. But I thought you were saying on the edge. Say you were looking on the edge of the frisbee or whatever you want to use for a shape. But if you're looking towards the edge of that, then yeah, you might see that curve. But that would be like one of the few instances that I would predict that you would see that curve. But you're not talking about that.
Is that what you think we think? Is it it's a disc in space or something?
No, I was just using it
space pizza
for the sake of example.
I was talking about the edges and the edge of the last bit of land you can see.
I got you. You're not, but
we could be on the top of a cube, bottom of a pyramid, all types of shit. Upside down pyramid. Top of a cylinder, maybe it's circular, maybe it's just a triangle, cuboid or some shit. Who knows? It could be tons of stuff. A pentagon.
But people on the globe side, what they're going to say, right? That if you set aside like atmospheric conditions that are probably going to happen between here and Paris, well, there should be no reason that you can't see Paris. The same reason that you can see stars, right? That would be the argument on the globe side. Like there shouldn't be a limit to your vision that where it falls off.
That's ridiculous. Unless
we can see the stars. That's fine.
Unless Paris is 2,000 miles up and 2,000 miles wide, they have at least one building that's that big and that's high. That's the only way you could probably see a speck of Paris from California or New York or whatever.
Do you think Paris is closer than the stars?
100%.
You do? Oh, wait, hold on. Did I say that backwards? Do you think, okay, so Paris is closer than the stars. Yeah. Yeah, but so why can you see the stars if they're further away?
Because you're not looking through anything and it's also some bright.
I mean, you're looking through the atmosphere to see the stars.
Yeah, well, I mean, I don't know what stars are. I mean, I know there's bright lights in the sky. Now,
yeah, that's why I qualified.
To be able to see something 2,000 miles away, it needs to be 2,000 miles high and 2,000 miles wide and bright.
That just doesn't make sense.
Oh, that's. I'm sorry, that's math. Go check it out. Look it up yourself.
I can look at the stars myself, and they're further away from Paris. You already said that.
Again, you don't know what the stars are.
You can see the stars on the horizon too, and you watch them disappear.
They are up high.
Not on the horizon.
Now, on Earth, look it up. It takes something. If it goes up flat Earth, doesn't matter what. It has to be 2,000 miles wide and 2,000 miles high for you to be able to see it.
Have you ever watched the moon rise on a night over the ocean? Have you ever watched that? It's really nice. It's really beautiful. But that's on the horizon, right? And you can see that, and it's much further away than Paris. From you? I don't know. They say like 3 miles, 3.5 miles. Yeah, but you can see the moon. The moon's way farther away. Are you saying that the moon's closer than Paris?
argument does it.
Yeah, it does, because the moon's further away than Paris, right? And you can see the moon.
Hold on.
So
Right.
your argument falls flat.
Well,
Hold on, just
how wide is supposed to be the moon?
It has nothing to do with it. You agree that it's further away than Paris, right?
Doesn't have nothing to do with it. But when I tell you something needs to be 2,000 feet, 2,000 miles wide and 2,000 miles high, so you see it from their distance of 2,000 miles
on the horizon.
Now, so for some reason, that's a problem now.
I just want to say that you people say that the horizon's only 3 miles away when you're standing at the ocean. That's the edge of the waterline that you can see. That's not things that are in the sky. They can be a long ass ways away.
Yeah, I'm talking about just the horizon as it falls away because of the curve of the Earth. But they'll say I'm saying more than I should. But that's what's happening at 3.5.
In West Virginia, I can stand on top of a mountain and watch a sunset in another state. Like you can see mountains in another state. That far away is the horizon.
But Elbow TV, you're right though. I wanted to just correct myself. Sorry, Cole. He's right that he did say that it needs to be big and wide and that you could see it. So on that point, yeah, you're right. I shouldn't have. But you said where do you see these observations from, Cole?
I don't even hold on. I don't think Elbow's right when he said that. You're telling me I couldn't get the biggest telescope we got and zoom in?
You should be able to, yeah. But what I'm saying is that he's just making an angular resolution argument. And yeah, Paris does need to be big enough for you to see it. But yeah, in theory, you'd be able to zoom it back in with a big enough telescope.
Oh yeah, we don't have a big enough telescope to do that.
I mean, we can zoom in on the moon, and that's way far away.
But that's with barring no optical effect.
Well, on the horizon, you can still see it.
Ground level, which...
That's why I asked about a moonrise, like over the water. You can see those. A full moon is what would obviously be ideal, but you can still see a crisp image of the moon rising above the water, and you can zoom in on it. So there's no reason you shouldn't be able to do it with Paris.
I just don't
like. Well, the angular resolution of Paris becomes really, really tiny compared to
the features on the moon are really tiny too, and they're way further away.
But it's up higher. It is way up higher than Paris is it not?
It's way further away. I mean,
it's way up higher and it's a shining bright light, is it not?
Okay, so from your vantage point, if you're looking and it's coming up over the horizon, it's not higher compared to you. Your perspective is straight out in front of you, just the same way that Paris would be. The answer to your question is
project light, yes or no?
It reflects light.
Which tomato? Does light comes off of it?
Yes, it does.
Okay, so and it's a lot higher than Paris is it not?
What was your point about lights? Paris has lights too.
Yeah, but the is the light from Paris that bright?
Probably.
Really?
I have no idea. I mean, there's a lot of lights in Paris, but I mean, I don't know. You can see it like you can see Paris lit up at night, like whenever you're looking at like satellite images.
Yeah, so I guess
the light from Paris was as bright as the
thing now. I'm guessing.
Like I'm talking about comparatively speaking. Obviously the moon's a fucking a sixth the size of the Earth. Sorry, go ahead. I'm just clarifying.
I guess light attenuation isn't a thing now. Then
I don't know, man. I was just saying that the moon is much further away and you can see it. And so there's no reason that you shouldn't be able to see other things. Paris was an example.
Not seeing it through a denser medium, are you?
Yeah, you are when it's coming up over the horizon.
It is still higher than anything you know.
It's not higher. It's not higher from where you are. It's straight out at the horizon where you'd be looking through a dense medium. So your argument's wrong.
No, it is higher. 100% higher.
It's elevation. Its elevation is higher. Yes, I mean.
Can we get back to your original
statement? You're still looking
that
through the densest part of the atmosphere, the same part of the atmosphere. Yeah, but let me finish this last point. You're still looking through the exact same atmosphere in theory, right? The same density that you would be looking at through Paris. That's why your argument falls flat. It doesn't matter if it's high up. You're looking through the atmosphere, just like you would be looking through the atmosphere to see Paris.
But it's a lot more brighter than freaking Paris and bigger.
Yeah, you're making an angular resolution argument.
Yeah, and bigger. Is it not bigger?
Yeah, of course the moon's bigger than Paris.
Is the same size as the moon.
No, you're asking me if I said that, and the answer's no.
So all right. So it is bigger.
Wait, were you confused? Did you think that I thought Paris was bigger than the moon?
Oh,
I'm sorry I gave you that impression.
You're saying you can see the moon, therefore you should see Paris?
Yeah, that's what I'm saying.
I mean,
and you're not giving an argument why I'm wrong. So
yes, we are. You're just not listening.
I've told
What's
you.
the argument?
One is brighter. 2 is bigger. 3 is elevated a lot higher than Paris.
Yeah, we've heard this like circular now. Do we have visibility living on a sphere? Like we live on a sphere, right? It's rotating, spinning 1 million miles an hour, going through space. And we look out over the distance. Do we have a limit to our vision?
No.
We don't?
No, you can see the stars.
So when you look towards the horizon, you can see everything except for what's below the curved Earth.
Yeah, you can see the stars at night on the horizon. Yes, and you can watch their path.
So no visibility limitations.
That's right. Eyes are receptors.
What?
Eyes are receptors. I'll say it again.
Okay, fine. Good luck, sir.
Thank you. You too.
He's saying as long as the light hits your eyes, you can see it, no matter where it comes from.
That's not what he's saying. He's saying there's no restriction besides. He's saying there's no restriction, Cole. It's set for Earth curve. That's why I put in the question. Other than Earth curve, is there any restriction to visibility? He said no.
I mean, you can't see behind the curve of the Earth. That was an example. You can see stars for as far as
Okay, can you see through a...
You're breaking up.
So a building doesn't fade out or blink out, even though it's not behind the curve, even on Earth.
It would fade out, and
it
would be an angular resolution. You wouldn't be able to resolve it with your eyes, but that's not what we see happen on the Earth. We watch boats go over the horizon. We can still see the boats when they go over.
No, you can't use that. No, we determined you can't use that anymore because you're too close to the surface. Remember, that was only about 20 minutes ago. Remember?
Oh, you mean the surface that you can see the clear moon coming up on the horizon at night? Yeah, that one. Okay, cool. Good argument.
The apparent horizon. Yeah, I watched it last week on the ocean, Gulf of America. It's beautiful. Yeah,
and you also forgot that refraction causes objects to rise up. So it actually works against your argument.
Why do you say I forgot that? I guarantee I've told more Globers that happens than Globers told me because they had no clue. Most Globers have no clue about that.
We got a new strategy, you guys.
Your apparent sunset is just apparent because it's already set. You're seeing an apparent sun, not the actual sun.
So in theory, if we were on a flat Earth, you should actually see the Earth above the middle of the frame because of refraction. So that's why it works against your argument.
I don't have that argument. I say that you see things in apparent positions due to the conditions of the day. You're the only one that has the argument. It works in a very specific way due to refraction.
That's what you school Globers on, though. You just said that yourself.
This isn't going to work, honestly.
I did not focus on refraction at all. I said that Globers don't know that. In their model, the refraction predictions of the sun setting is that the sun is already set and it's loomed up due to refraction.
That's right.
Who doesn't know that?
No, most Globers don't. I'll take the bet
I
right now.
disagree with that. I disagree with that.
Okay. Well,
You're going to talk about Globers in the argument, or are you going to talk about your average daily Joe you meet on the street?
Probably average.
Well, any Glober. Ask somebody if they believe in the globe, and they're going to say yes, and then ask them if they know that, and I guarantee I'll take any of my money.
Dude. Yeah, but what you're doing is you're qualifying these people as people that have actually taken part in like trying to figure out what we live on. And the average Joe, what Left Lane is saying is the average Joe wouldn't know anything from Adam. They probably wouldn't know the amount of degrees on a triangle, etc. Right?
Yeah.
So it's just people in the argument.
It's just
so how does that help your argument?
It doesn't help.
It helps my argument. Is that my point was that the normal Glober doesn't know. They're just in a religion. They take it on faith, blind faith. They were taught things, right, that they believe on the globe and have no clue about the effects. Because when you do discuss these things, right, when you do tell Globers that the water curves away from their feet at 8 inches per mile square and it's never been measured, and how planes and boats circumnavigate on a sphere versus a flat plane, they start to realize, holy shit, it could happen both ways. Like, oh my God, that's how I did it.